What if I told you there's a way to connect remote offices cheaper than MPLS and more secure than standard VPNs? Most network engineers waste thousands on expensive leased lines while overlooking these three game-changing protocols. In this video, I'll reveal how PPPoE, GRE tunnels, and BGP can revolutionize your WAN with real-world configurations you can implement today. Stick around, your network budget will thank you. PPPoE, GRE tunnel, and eBGP. PPPoE stand for Point-to-Point over Ethernet. In the early days of the internet, we used, remember, analog modems, which were also known as 56K modems. This modem made it possible to switch from the digital signal of our computer to the analog signal, that of our telephone line. Well, the protocol used on this type of modem was PPP with CHAP authentication. This allowed the internet service provider to identify each of its customers and see if they were up to date with their payments. Then came the ADSL type modems. With this type of modem, internet service providers did not have a solution to authenticate their customers because there was no longer a PPP link, but an Ethernet link. In order to continue using CHAP authentication, it was necessary to successfully encapsulate the PPP protocol through the Ethernet protocol. Well, that's how the PPPoE protocol was born. It allows you to create a layer 2 tunnel between two routers. It takes 8 bytes, and it can only be used on point-to-point links. That is, a tunnel PPPoE can only be mounted between two routers directly connected. Here we have two routers interconnected with each other, and we will configure router 1 as the PPPoE client. Router 2 is on the carrier side, so it's already set up. To begin, one must create a dialer interface to manage the connection and attach it to a physical interface that will provide the transport. The interface is created with the command interface dialer1. The command IP address negotiated allows the client to be asked to use an IP address provided by the PPPoE server. The encapsulation command sets the encapsulation type to PPP, and the dialer pool command allows you to specify a dialer pool on the interface. Then, all that remains is to associate our fast Ethernet 0mol1 interface with the dialer interface that we have just created with the PPPoE client dial pool number command. With a show IP interface brief, we see that router 1 has obtained an IP address of the PPPoE server, which is router 2. This IP address is located on the virtual interface, not on the physical fast Ethernet 0.1 interface. The show PPPoE session command displays the sessions that are established. Tunnel GRE, generic routing encapsulation. We will now talk about the GRE tunnel. It is a process of encapsulations that allows any protocol from the network layer to be carried in packets that are themselves from the network layer. That is to say, we can very well encapsulate IPv6 in an IPv4 packet so that the two remote networks in IPv6 can communicate. On this topology, we have two private networks, which are geographically distant. If we want to interconnect these two networks, well, there are two possibilities. The first, which is quite expensive, is to use a dedicated line, which would be rented directly from the operator, for example, an MPLS type technology. And the other possibility, which is relatively cheaper, is to interconnect these two networks with the internet. The GRE tunnel makes it possible to create a dedicated virtual line, which will pass through the internet and which will function almost like a dedicated link. The main advantage is that you are not dependent on an operator and that you can choose the internet output of each site that needs to be connected yourself. We're going to end the course with the External Routing Protocol, which is BGP, Border Gateway Protocol. It is a route exchange protocol that is used mainly on the Internet. Its purpose is to exchange routing information between autonomous systems. Unlike internal routing protocols, BGP does not use metrics. That is, it makes its routing decisions based on the rules set by the AS administrator. BGP is a path vector routing protocol. Communication between routers is done with a TCP session on port 179. BGP is the only routing protocol that uses TCP for transport. There are two versions of BGP, IBGP, EBGP. The IBGP is used inside an AS, whereas EBGP is used between two ASs. BGP is mainly used for interconnections between Internet operators. It is part of the EGP family, of which it is now the only member. It is therefore only useful if you are an operator. IGP routing protocols, such as RIP, EIGRP, OSPF, or ISIS, is only used within a company. Their goals are to find the most efficient route, trusting other routers, while the EGP routing protocols, such as BGP, are used on standalone systems. GRE Tunnel VPN configuration. In this course, we're going to look at setting up a VPN with a GRE encapsulation. The GRE protocol allows IP packets to be placed in another packet so that it can be sent through a tunnel. As we can see on this topology, the GRE tunnel looks like a normal link, except that it's virtual. So you have to configure an IP for it, and you will use the 192.168.10.SRU network. Router 1 carries the IP in point 1, and Router 2 the IP in point 2. Let's move on to setting up a GRE tunnel to see how it works. Routers 1 and 2 can join each other, thanks to the Internet Service Provider's router. To make things more interesting, we're also going to set up OSPF routing so that the two local networks can communicate through the Internet. We're going to start by creating our GRE tunnel. The tunnel interface command allows you to create the tunnel, just like an interface. Here we choose interface 1 of the tunnel. Then we need to configure a source IP and a destination IP in our tunnel. We take the public IPs of our routers to build this tunnel. Now that our tunnel is in place, we're going to assign it an IP address. Just like any other interface, you have to put an IP on it. Now our GRE tunnel runs correctly. We'll continue by configuring OSPF so that routers 1 and 2 can communicate. Don't forget to add the tunnel network to form a good neighborhood adjacency.